Thank you for joining the session. Welcome to everybody who's here. My name is Cora Iverclyde. I'm a developer advocate at VMware, and this session is Carvel 101 for streamlining your, should I hit enable here? Sure. For streamlining your Kubernetes workflow. So let's get started. So here's a disclaimer. Maybe you've seen it in other presentations. You can read it on the recording. Okay, so agenda is, what is Carvel? And then we'll do a demo. So what is Carvel? So this is taken straight out of the Carvel website. Carvel provides a set of reliable, single-purpose composable tools that aid in your application building, configuration, and deployment to Kubernetes. And some of the more like the resources are listed down there. I'll share those at the end again. So basically, Carvel is a set of different individual tools, right? So here you see the set of tools that comprise Carvel. I'm going to make an attempt in the time that I have to cover all of these. So you're going to get a really good coverage. So diving into this definition a little bit, what does it mean that it's single purpose? So each one of these tools, like here you see 3 of them, YTT, kbuild, cap, does one thing, right? Process YAML, handle image tags, applied YAML to Kubernetes. And they're composable because every one of these is YAML in, YAML out, YAML in, YAML out. So you can just pipe the YAML from one to the next. And you can do that not only between the different Carvel tools, but you can also combine it with any other tool that is a kind of YAML in, YAML out kind of tool, like Customize, Helm, kubectl, et cetera, right? So here you see you're only using kbuild on the bottom with non-Carvel tools, so composable that way too. Now, for the scenario of the demo that we're gonna do today, the situation is that we've written an app. It's called Hello App, really simple, kind of a hello world kind of thing, except it also uses Redis to keep account of how many times you've called a particular endpoint. And when it says hello, it also tells you hello and how many times you've called that. You can see here, hello sunshine 4. So this app is so cool that all of our friends also want to deploy it. And not only that, but our coworkers also want to deploy it. Now, the difference between our friends and coworkers is that our friends are going to deploy it to Kubernetes clusters that have access to the internet, and our coworkers are on air-gapped environments, which means that their Kubernetes cluster can't reach out to a public registry to download an image, right? Or any configuration. Everything has to be on the local network. So we could just be like, well, here it is on GitHub. So make sure you've got Redis. It's just a prerequisite. Figure it out. Clone the repo, build the image, upload it to whatever registry you can access, create some YAMLs, look at the Kubernetes docs, and then deploy it. And then every so often, just check back with me because maybe I'll update the app, or maybe Redis has an update. So then you might want to update what you have. We could do that, but we can do a lot better than that. You could do better than that with like normal tools, right? Like you're just give them the YAML, use Customize or Helm or anything you can, or give them some help in terms of which Redis to choose and how to deploy it. But we're specifically going to focus on how much better we can do with a Carvel tool suite. So that's the setup. Now, the demo. All right, as I mentioned, we have a very simple app. It's just a hello application. I'm not really going to go into that code because it's not worth it. It's really simple. So it's just helloapp.go. It's written in Go. And that's really all we have right now. So if I wanted to tell you how to run this on your local computer, I would say something like this. Use Docker run and get this Redis image from like Docker Hub or something, and then CD into the source code and just say go run hello app go, and that'll be running on your local machine. And then if you want to deploy this to Kubernetes, you figure it out, everything that you need to do. So as we think about how to do this better, we're going to start with this. We're going to start with the fact that there is a Redis dependency. And so we're going to include that, everything that our friends and coworkers are going to need to deploy the Redis itself into our application. And we're going to do that using a tool called Vendor, which is the first tool we're looking at from the Carvel tool suite. Now, I've chosen this, here's this repo. I'm just going to open it and show it to you here. This repo has four YAML files, 2 deployments, and then 2 corresponding services because it's a leader follower configuration for Redis. So this is just, so pretend this is like some third-party kind of Redis source. It could be, for example, maybe the Bitnami Redis that has Helm. You could pipe the Helm into the YTT that I'm going to show you. But just to keep things simple for the demo, I'm just using these 4 files. I personally got these. I just copied them from this website, Kubernetes website. They have some example application guestbook thing here. So I just copied those into a smaller repo so that the demo would be faster because this repo is huge. So basically, we're going to pretend that these are third-party files that we're pulling in. So we have to tell vendor, hey, go get those files. So we do that by providing vendor with a configuration file. So this configuration file says, go to this repo that I just showed you, go to the main branch and get all of the files that start with Redis, which is really just going to leave out the README in this case. Get that stuff and put it in my local directory under config/dependencies/Redis. So the way that we call that is to say vendor sync, and we're going to go to the directory where this file lives, which is in bundle. It'll find vendor.yaml automatically. So we run that, it goes, it clones the repo, and we're all good. So what did that do? So let's look at a git status. So we can see that we have new files in our clone of in our source code directory. We have the 4 YAML files that we expected, right? The 2 deployments, the 2 services. And we also have this extra file called vendor lock YAML, which that's interesting. So let's look at that. And we see that actually this has information about the exact commit that it pulled. So this time it pulled commit main, right? Now, if we wanted to do this again later, but wanted to guarantee that we get the same commit, so we're guaranteeing the version of Redis that we're saying is going to work with our code, we could do it again and use the locked flag. And then it's going to do it again, but it's going to pull not from main, but it's going to respect that lock file, and pull it from that particular git commit. So that's one way to manage the files that you're including or distributing. So that is vendor. So that's really cool because now our repo has, on top of our source code, it has files for deploying Redis to Kubernetes. Now, there's more YAML that we need, of course, right? We need YAML for our Hello app application as well. And for that, we're going to use YTT, which is the YAML templating tool from Carvel. It does both the templating style that sort of Helm does, a little differently, but kind of Helmish. And it also does the overlay style that Customize does. And we're going to show you both right here. So first of all, we have a configuration file for the service and the deployment, right? We have to write that file initially, right, for our Hello app. So here it is. So we have a deployment and a service. And you can see that this YAML file is annotated with a bunch of like code here, right? So essentially this code is written in a language called Starlark, which is a dialect of Python, and that YTT knows how to process. Every one of these pieces of code is put inside of a comment. So everything is behind a hash. So from a YAML perspective, they're just comments. From a YTT perspective, it's hash at space. So that tells YTT this is a piece of Starlark code. If you wanted to write your own comments here, you could do hash ! And then YTT would know this is not code, this is just a comment. But right now, YTT knows that this is Starlark code. So if you think about this annotation as a programming language, it's a little bit easier to wrap your head around and to kind of get used to reading it. And eventually, I think at the beginning, it looks really confusing, but you kind of approach it from that angle, then it's a little bit easier to absorb. So you can see you can do things like programming, like string concatenation here. We're doing concats. And then we're also, if you look higher in this file, we're loading a module. So think something like, I don't know, like import something into your Java class file, right? And you can define functions here. We're defining a function that would return a snippet of YAML app and then a custom value that we're going to bring in from somewhere else that I'll show you in a second. And this function is being used in here. So when I want to set the selectors on my service, I want the selector to be app and then the name of the app. So this function is going to call this, and then that's going to resolve based on this source. Everything that's resolving to a value, a customizable value, is coming from this data values. So that's generally the Starlark code that you can put in into your YAML. So let's look at that. Where are all these values coming from? So we have a file here called default values. It's annotated also with this module here, data values, which matches all these, right? Data values, and then Hello app name, for example, is going to be Hello app name. So that would be Hello app by default. Or like the namespaces that we're including here are going to be namespace, data values, namespace name, data values, namespace name is going to be Carvel demo by default, right? There's some other like cool things that you can do to flip on things or flip off. If this is set to true, it'll include a namespace. If not, if it's blank or null, then it won't include a namespace. But basically, that's how YTT is going to resolve that. And so these are default values. and they're processed with all of the other YAML files. You can also have a second values file that is for non-default values. This one doesn't have an annotation because it's going to be specified with a particular flag to YTT. It just is pure YAML. So this is something that would be easier for like our friends and coworkers to add on top without having to, include this annotation. And then they can overwrite these values however they want. So let's process all of that. So we're going to run YTT. Oh, wait, sorry. Before that, let me talk about the overlays, right? So we've looked at templating in order to make our Hello app service and deployment and maybe a namespace customizable and manageable. Now we still have those Redis ones that we downloaded from the third party, and we want those Redis ones at least to be in the same namespace. Maybe we want to change the names in case we want to deploy multiple instances. So for that, we don't actually want to change those Redis files directly, because then we won't be able to download updates to that third-party repository. So rather than that, we want to use overlays. So here's an example of the overlay for Redis. So here we have a second module that we're importing, and we're going to use this function to say that we're looking for a YAML snippet, metadata labels app Redis, because only those 4 YAML files that came from that third-party repo have this value as a label. So then we can use this function here and say, we're looking for YAML that matches those conditions. So this is going to filter in those 4 files, and it's going to filter out our service and deployment for Hello app. So then for those, it'll change the namespace. Or maybe more specifically here at the bottom, here's another example where it says, okay, I want you to find the YAML file that it's a Redis one, so same condition, but also it's a deployment, it's kind deployment, and also it's the role of a follower. So this will only match the one file that's a deployment for the follower in the leader follower, right? And for that one, we want to add some environment variables. We're going to overlay this snippet of YAML so that the follower can find the leader, because we're going to change the leader name. So that's basically how the overlays work. So this is changing the Redis YAML without actually modifying the YAML that we downloaded from the third party. So, okay, so now let's run that YTT stuff. And so really simple, you just give it to YTT, YAML in, YAML out, right? So, and there it goes. It's resolved everything. So you can see here our namespace is Carvel demo. That was our default. All the names have been changed to prefix Hello app. Here's that Redis. This is the overlay that we were just talking about for the follower to find the leader, and so on and so forth. Everything has been resolved really, really nicely. Now we could just feed this. This is just YAML, so you could feed this to kubectl apply. You could give it to your friends and coworkers. This would work fine. At least for your friends, it would work fine. But we can do better. And one way we can do better is that everything has a tag on it. And in fact, our Hello app one is like latest. So it would be more reliable if these were SHAs. So let's do that. Let's put SHAs in there instead. So there's a tool called kbuild that helps you do that automatically. It'll actually go find the image on the respective registry and then do the replacement in the YAML. So if we pass all that configuration to kbuild, and so these are the 3 images that we're looking at, right? Those are the ones we want to change. We're going to pass that configuration to kbuild. And first we get an error. And the reason that we get an error is because this image doesn't even exist, right? All we have is source code or Go source code. We didn't actually make an image yet. So let's go ahead and correct that problem first. And actually kbuild can help us with that as well. It can actually orchestrate builds. It doesn't do the build, it orchestrates it, meaning like you can still use like Dockerfile for your build or build packs, and kbuild will just kick that off. So here's a configuration to tell kbuild to actually build our Hello app image. We're telling it, hey, our source is in our source directory, and the mechanism I want you to use to build it in this case is build packs. We're using the Paketo build packs. Here's where if you were using Dockerfile, you have to supply the Dockerfile, which is what I'm trying not to do by using build packs. And you could configure this with the syntax to say that you want to use Dockerfile if you want. But right now, build packs are really cool. If you don't know about them, I would recommend learning about Paketo build packs and the buildpacks.io project. And then once this is done, you're going to have an image on your local Docker daemon. Now that's not good enough for Kubernetes, right? Kubernetes needs to be able to access it from a registry. So we want to push it somewhere. So here we're going to set a destination. And by saying new image is this, it's actually going to do that Docker push I'm running a local registry on a kind cluster. But if you were doing this, for example, on Docker Hub or GCR or whatever, you would just change this address and it would push it to the right location. So now we can add that information, give that configuration to kbuild. And also I'm going to tell kbuild, hey, by the way, I know you're going to spit out the YAML that we could deploy to Kubernetes, but can you please write this other file that has the information about the SHAs that you replaced so that I can also use that as a lock in the future, so that I can guarantee that these are the replacements that would be done. So so this output that you're seeing here right now is the build by the build packs. So kbuild is telling pack to go build that image for us. We'll give it another little bit of time here to finish. Just a moment, so it's going to process it. So build packs are basically taking that Go code, making an image out of it, putting it on the local Docker daemon. They're almost done. And now, okay, now they're being pushed. Now that image is being pushed to our registry. And that information should be written to a file, but also kbuild has spit out YAML. So this YAML now, you can see the images don't have tags. Now they have SHAs. So now this YAML is much more reliable. If it's installed in different times in different places, we have a much greater guarantee of what's exactly going to be installed. Now that file, well, first of all, here's the image. So here's the image that was built by Pack and published to the registry. So that's also living out there right now. So now that's available to anyone who wants to deploy. But that file that was written out, you can see here, it says, you know, Redis 605 is this SHA, and the Redis follower, and the hello app latest is this SHA, right? So if I delete this file, then it would rebuild this app and go back out to the internet and figure these out. But if I leave this file here, it won't do that again. So if this changed, if this is 605.1 actually, and then 605.2 comes out, then if I delete these 3 lines and run this again, then it would go out and find a different SHA because 605 would have changed. But if I keep this file here, then I know that we're using the same 605 that we're using right now. In order to do that, I'd have to use this lock file as input as well. Before we used it as like an output destination, we would have to also say we want it to be input. So here we're saying to YTT to also pick up that file, give that to kbuild. So now kbuild says, okay, I have to process this, but also I'm going to use this lock file that's already existing. And if there's anything to change, like if something's missing here, then it would update it. But so let's run that. And so that's really fast because it didn't redo the build, right? It just used it. And you can see actually here that the first time this would have said, it adds some metadata to say that kbuild has resolved these things. In the first one, it said resolved. Here it's saying pre-resolved because it got them from the existing log file. So, okay, so that's kbuild. How am I doing on the time? Okay, so, all right, wow, time flies. Okay, so then we've got packaging and distribution. Now we could just give that YAML to our friends and coworkers. That's pretty good, especially for our friends, because they can reach those images. But we can do a little bit better. So there's a tool called Image Package that's also part of Carvel that allows you to package files as an OCI bundle, so then you can share them through a registry. So rather than giving them like I don't know, just the file, just the YAML file, or putting the file on a Git repo. So we're going to push everything in the bundle directory. So that means it's not just the config files, right? This is the config file. This is a configuration that YAML, that YTT works with, but we're also including the lock files for the images, for kbuild, for the Redis vendoring, everything that's in this bundle directory. We want to put that into something we can share. So that's what we're doing in this case. Everything in that bundle. So here's all of the files. They're now put into an image, and that image has been pushed to my registry under this tag. Right, so we can check that in my registry. I have the bundle, and yes, okay, I have the bundle there. So now I can say, everybody, hey, just go to this registry and do a Docker pull or something on that bundle. Not a Docker pull, but pull that bundle. So, okay, so now our friends are actually set. That's all they need, right? Our friends can use image package to pull that. So it's different from Docker pull, right? They're going to use image package to pull this, and then image package is not just going to download it, but it's also going to extract it. It's going to extract it to the directory of their choice, in this case, temp hello app bundle. And so now that it's extracted, if we look at the contents of that directory, it actually has the same thing that we had in our bundle directory, all of the same stuff, just unzipped all of it. So now they could run all of those commands, or they could add their own extra values file. They could change the namespace to friend zone, change the default message of the hello app. They set owner to true, then they will include a namespace, whatever they want, extra values. And then they could use the same tool suite to process the stuff. So they would run that, they would get their YAML. So now they have hello friends coming from their own value file. They have all the things that we locked in, so we can guarantee those versions will work, etc. Right? Friend zone, they put their own namespace through their own values file. So all of that has been processed. So our friends are set. They can apply that to Kubernetes, but our coworkers are in an air-gapped environment. So that YAML is not going to work for them because it's referencing images that are on Docker Hub, on GCR, and on wherever we put a hello app. So for them, there's another command within image package called copy. That's really cool. So this one is going to copy. It doesn't just copy this image as is. Rather, it looks inside and says, what other images does this reference? I'm going to copy each one of those individually. And then also, because as I copy these, the address changes, then I'm also going to update the references in the image package file to those addresses so that it's resolved correctly. So basically, let's pretend that this command is being run on like a jump box that has access to the internet, which is this, and access to the internal registry, which is this, right? Otherwise, you could use like you can create a file, copy it over on a stick or something. But anyway, you can see that it copied 4 images, right? So the bundle, the hello app, the Redis leader, the Redis follower. And now if we look inside of our registry, this is the internal registry where we copied 2, you can see that under this, there's actually various tags. Each one of these tags is a different one of those images. So now our coworkers can pull that into a local directory on the intranet in the corporation. And now they'll have the same set of files. So for example, here, if we look at temp, so our friends pulled into their own directory where they have the image package, the config, everything. And our coworkers have done the same, but they pulled from their internal registry. So they've got the same set of files, but there's a difference between these files. And that difference, we can do a diff on the image package log file, on the images.yaml file. And you'll see that our friends have references to Docker Hub, and our coworkers have references to their internal registry, or our friends have GCR, and our coworkers have to the internal registry. And again, friends have whatever public registry we put our hello app into, and our coworkers have references to the internal registry. So that's also been changed. So now our coworkers can do the same command, but when they do it, their images.yaml file automatically has been updated by that copy command to point to their internal copies of all of these things. So when they, I just saved it to a file, so let me show you the file. When they produce the YAML, now they have, everything is pointing to their internal registry. So, so now our coworkers, this will work for our coworkers. They have everything that they need internally. So that's really cool. So, okay, so we've covered a lot of ground. Now, what about applying it to Kubernetes? We could just do kubectl apply, but Carvel has a tool called cap that does some things that kubectl apply doesn't do. So here we're going to do very similar. So instead of kubectl apply, we do cap deploy. We give it all of our YAML. I saved it to a file, so it's just a bit shorter. And but it has an extra parameter called -a or -- application. So it has this concept of treating everything like an application. Everything is together. It knows that these things are related. It'll also take all of the things that are in here and it'll order them. So it'll do the namespace first, for example. Okay, so then we can do that. So another thing that it does is it shows us, before it does anything, it shows us what it's about to do. What's in this file anyway? Well, we see it's a namespace, 3 deployments, 3 services. And it says it's going to create them for the first time. So do we want this? It prompts us, and we can say yes. And so then it does it, and then it waits for it to be done before it. Sorry, just checking time. 25. Okay. It waits for it to be done before it closes. So a lot of things that kubectl apply doesn't do are included here. If we wanted to make a change, for example, let's say I want to change this. I want to say here team instead of colleagues. Let's see. And so then I could come back out here and say cap deploy that again. And then I'm going to say here, as you're deploying that again, I want you to diff the changes between what's out in Kubernetes and what I'm about to deploy, because I don't really, I don't know what changed in my files. So I'm going to do that. And it says, oh, here is the change. You changed the value from colleagues to team for your hello message. And so then I'm like, oh, okay, that's cool. Go ahead and do that. All right. So that's another thing cap does. So ordering, prompting, diffing, waiting. It also can give you a list of all the cap things, all the applications you deployed with cap. So far, we've only deployed one. The way that it keeps this in the background, just behind the scenes, just so if you're curious, cap actually creates config maps for the applications and the changes that you've done. So that's kind of how it's doing it. You can also use it to inspect any application. You can use this minus tree to look really good at the different resources that are there. So here you see that our application is in the co-working space namespace, and it's all these resources. It shows you some things that kubectl get apply doesn't, kubectl get all doesn't. Also, okay, so we can do logging. So let's do logging. Sorry, there's some things on my screen. Okay, so logs. So I'm going to run cap command logs for this application, and I'm going to look specifically for containers called hello app. That's my hello app name, and I'm going to use a -f to tail it to follow it. So here's the logging. You can see that we have 3 replicas. They're all started. Just going to highlight this so we can keep track of what the last line was. Now here, so there I can see, so already you can see it's helpful to get logs across containers for an application. I could also do that with all containers or the Redis containers. Now here, what happens if I delete one of these? Let me randomly pick up this pod, let's say. If I delete this pod, now Kubernetes, of course, the deployment is going to recreate that pod. But what happens to my log stream? So we go over here, we see actually it continues and a new pod was started and it captures that as well. So that's really cool from a logging perspective. Another cool thing is, normally, if I would want to send traffic to this app, I'd have to do like a kubectl port forward or something. So there's a tool called KWT, which my coworker Whitney calls cute. That one is sort of like it's the equivalent of kind of like port forwarding to everything and to all of the services in your cluster. So first of all, let me start that. So you would start it like this, and then you actually do have to give your computer password. Okay, so that starts up, and now I can actually access any service in the cluster, and this also will stay alive even as things go up and down in the cluster. So much easier to use than port forward. So here I want to talk to hello coworkers, right? These are the ones in my co-working namespace. So I can just say curl and talk to it as if I was in the cluster. Actually use the internal DNS and send it a request, and there it is. And so then something else that I can do is since I'm managing the application as a whole, I can also delete the application as a whole, and that will go ahead. Again, prompt me, are you sure you want to delete all of these things? And I'll say yes, and I don't need to have had that original YAML file, because when you're using kubectl, you need to have the original YAML file to make sure you've deleted everything you first deployed. But here we can rely on cap to keep track of those relationships and delete everything for us. So that's my whirlwind tour. Let me go back to the slides here. And 29, 23. Okay, so that's that. So that's the recap. So we touched on all these tools. We started with vendor, we did YTT, we did kbuild, image package, cap, and even KWT. I hope that gives you a really good idea of what Carvel does. Again, these are the resources that I shared earlier on the first slide where you can learn more. This is the demo that I just went through, so you can do that on your own. And that's it. Thank you so much. Wow, 30 minutes on the dot. Please take the survey so I can improve this presentation. Let me know if it was useful. And thank you so much for your time today. I really appreciate your presence here.